Friends, welcome to Bank Exam Cafe, and in today's episode on some applications of trigonometry, we are going to see few more questions. This is the part 7, and previously we have uploaded 6 parts, and the links of all these 6 parts are given in the description box. I request you to watch all those 6 parts so that the idea of the questions that are asked in the examination you will get acquainted with, and also you will come to know how to deal with such questions and how different types of questions are being asked in the examination. So please watch all these 6 parts, and now we will move to the first question of this episode. Here is the question on the screen. From a point on the ground, the angles of elevation of the bottom and the top of a transmission tower fixed at the top of a 20-meter high building are 45 degrees and 60 degrees respectively. Find the height of the tower. Friends, here BA is a building, and on the top of the building there is a transmission tower CB. So BA is a building whose height is given as 20 meter, and on the top of this building there is a transmission tower. Let that transmission tower be BC and assume that its height is H, and from a point O, which is on the ground, the angle of elevation of the top of the transmission tower and the bottom of the transmission tower are 45 degrees and 60 degrees respectively. So the angle of elevation of the top of the transmission tower is 60 degree from point O, which is on the ground, and the angle of elevation of the top of the building or the bottom of the transmission tower means the B point, that is 45 degree from the point O on the ground. And friends, we have to find the height of the transmission tower. So let the height of the transmission tower be H, and this height of the building is 20. Now we get two right angle triangles here, that COA. This is the first right angle triangle, and the another is triangle BOA. This is the another right angle triangle. With the help of these two triangles, we will find the height of the transmission tower. So first we will take triangle BOA. So in triangle BOA, here tan 45, that is equal to opposite upon adjacent. So opposite side is 20 meter, that is the height of the building, and adjacent side is OA, that we do not know. So tan 45, which is equal to opposite side is 20 upon adjacent side is OA. So tan 45 degree, that is 1, which is equal to 20 upon OA, and therefore friends, cross multiply, you will get OA, that is equal to 20 meter, and so this distance OA is also 20 meter. Now we will take the triangle OCA. I solve this further. Here triangle OCA, in triangle OCA, here we can solve this. In triangle OCA, tan 60, that is equal to opposite upon adjacent. So opposite is AC, that is height of the building plus height of the tower. This total is the opposite side, and therefore it will be H plus 20. So tan 60, which is equal to opposite, that is H plus 20 upon the adjacent is 20 meter. This is the adjacent side. Now here the value of tan 60 is root 3. So root 3, which is equal to H plus 20 upon 20. Now cross multiply, this will be 20 root 3, which is equal to H plus 20. Now take 20 to this side, this is plus 20, it will become minus 20. And so h is equal to 20 root 3 minus 20. Take out 20 as a common factor, so you will get h is equal to 20 into bracket root 3 minus 1. So the height of the transmission tower is 20 into bracket root 3 minus 1, close the bracket, meters. And friends, if the value of root 3 is given as 1.73 in the question, then put the value of root 3 and solve this further to get the value of h, that is the height of the transmission tower. So this is the way we can find the height of the transmission tower in this type of the questions. Now let us see the another question which is of the same type. The question is that an aeroplane, when flying at a height of 3125 meters from a ground, passes vertically below another plane at the instant when the angles of elevation of the two planes from the same point on the ground are 30 degrees and 60 degrees respectively. Find the distance between the two planes at that instant. Very simple question, same as that of the previous. Here B is a plane flying at a height of, so here friends, A is a plane that is flying above the height of a 3125 meter from the ground, and at a particular instant another plane B that passes below this plane A. So at instant these two planes are vertically above one another. So here the angles of elevation from a point on the ground, suppose that point is O, then the angles of elevation of the two planes from this point O are given as 60 degrees and that of the another plane B as 30 degrees. And we have to find the distance between the two planes. This distance we have to find. AB distance that we have to find. Very simple as that of the previous question. So first we will take this triangle AOC and then we will take triangle BOC. Now here in triangle OAC, in triangle OAC, tan 60, that is equal to opposite upon adjacent. So tan of 60, that is equal to opposite is what, AB upon BC. This total is given as 3125 upon the adjacent side is OC. Now friends, here tan 60 is the value of tan 60 is root 3. So root 3, which is equal to 3125 upon OC. Now solve this further. So take OC to this side and root 3 to this side. So it will be OC is equal to 3125 upon root 3. Here we have got the length OC, that is 3125 upon root 3. Now I solve the next here. So we will take this another triangle, triangle BOC. So in triangle BOC, tan 30, that is opposite upon adjacent. Opposite is BC and adjacent is OC. So tan 30, that is equal to BC upon 3125 upon root 3. Now here this will be tan 30. Tan 30 is 1 upon root 3. So it is 1 upon root 3, that is equal to BC upon 3125 upon root 3. Now we will take this denominator to another side and we will get BC. So here friends, we will solve this. So if you take this to this side, it will be 1 upon root 3 multiplied by 3125 upon root 3, that is equal to BC. And now here root 3 into root 3, that will be 3. So that will be 3125 upon 3, which is equal to BC. So we have got this BC, but we have to find what we have to find. We have to find AB distance. This total distance is 3125. Out of this we have got 3125 upon 3. If you subtract this from 3125, you will get AB. So here to find AB, we will get AB is equal to this is 3125 minus this is 3125 by 3. Solving this further, we will get it as, so multiply by 3 to the side, and so that will be equal to and subtracting this, you will get it as 6250 upon 3. If you solve this, you will get it as 6250 upon 3. You can take 3125 as a common factor. Then inside the bracket it will be 1 minus 1 upon 3. 3 ones are 3. 3 minus 1, that is 2 upon 3. And then solve. So twice of this upon 3. So that is equal to, if you solve this, you will get 2083.33 meter. So here the distance between the two planes is 2083.33 meter. So at the end you have to write that distance between the two planes, is equal to 2083.33 meter. So here we have seen two questions on heights and distance or applications of trigonometry, and I hope you must have enjoyed this video. If yes, please like the video, share it with your friends, and do not forget to subscribe the channel. Also press the bell icon so that the notification of the newly uploaded video will reach to you and you will not miss any of the video. So friends, thank you very much for watching this video.